So our problem is the integral of square root of 2ax minus x squared dx. The next step is that we add and subtract the a squared. So the integral of square root of a squared minus x squared plus 2ax minus a squared dx. Next step is that the integral of square root of a squared plus combine these three, negative x squared plus 2ax minus a squared dx gives us integral of square root of a squared minus quantity of x minus a squared dx. If we expand this form, the result is x squared minus 2ax plus a squared. And then, from this, we can use a trigonometric substitution in which we let x as a sine theta. In here, we use x minus a is equals to a sine theta. So we must find the derivative of this equation. So the derivative is the derivative of x is dx is equals to the derivative of this, which is a cosine theta d theta. And then x minus a squared is equals to a squared sine squared theta. And then we substitute all the x's in a sine theta. So the integral of square root of a squared minus a squared sine squared theta times the dx, which is a cosine theta d theta. And then the a, which is the constant, brings out from the integral sign. So a integral of square root of a squared times 1 minus sine squared theta times cosine theta d theta. So 1 minus sine squared theta has an identity of cosine squared theta. So a integral of a squared times cosine squared theta times cos theta d theta. In here, we can cancel the square root and the squared in here, which is the a and the cosine squared theta. So it gives us a, the integral of a cosine theta times cosine theta d theta. In here, a, we can bring it out outside the integral sign. So it gives us a squared times combined cosine theta times cosine theta gives us cosine squared theta. From cosine squared theta, we have the identity of 1 plus cosine 2 theta over 2 d theta. A squared, which is the constant, and 2, which is also a constant, can be brought out outside the integral sign. So a squared over 2, integral of 1 plus cosine 2 theta d theta, we can distribute it. So d theta plus cosine 2 theta d theta. Also, this one, the constant, will be distributed rather in each term. So it gives us a squared over 2, the integral of d theta plus a squared over 2, the integral of cosine 2 theta d theta. So a squared over 2, the integral of this is theta plus a squared over 4. The integral of this is sine 2 theta plus c. But we need to let sine 2 theta equals to 2 sine theta cosine theta. So it gives us this equation. And then we use the right triangle in order to bring back the equation into 2ax minus x squared, in which sine theta is equals to opposite, which is x minus a, over the hypotenuse, which is the a, and the cosine theta, that gives us adjacent, a squared minus x minus a squared over a. And then from here, sine theta is equals to x minus a over a. It gives us theta is equals to arc sine x minus a over a. And then we substitute all the theta in x terms. So a squared over 2 arc sine x minus a over 2 plus a squared over 2 times the sine theta x minus a plus over a times the cosine theta, which gives us a squared minus x minus a squared over a. So in here, a squared cancel both the a's, and then it gives us this answer: a squared over 2 arcsine x minus a over 2 plus 1/2 x square root of a squared minus quantity x minus a squared minus a over 2 square root of a squared minus x minus a squared, or the quantity of x minus a squared rather, plus c, and this is our final answer.